Section 8.1, Completing the Square. By using a method called completing the square, we can use the principle of square roots to solve any quadratic equation. The principle of square roots states that for any real number k, if x squared equals k, then x is equal to the square root of k, or x is equal to the negative square root of k. Relatively easy equation to solve. By using this method called completing the square, we can transform any quadratic equation into something of the form that we can use the principles of square roots. And these are the steps needed to complete the square. The first one is to isolate variables to one side of the equation. Next, we want to divide both sides by coefficients of the x squared term, if not 1. Next, we want to divide the linear term, we'll call it the x term coefficient, by 2, square it, square the result, and add to both sides of the equation. Next, we want to express the trinomial as a perfect square. Whoops. And simplify other side. Next, this is the easy part, take the square root of each side, and finally solve for x. Let's see what these steps mean in practice. They're asking us to solve by completing the square. So the first step is to isolate the variables to one side. Well, it's already done. Next is to divide both sides by the coefficient of the x squared term if it's not 1. Well, our leading coefficient is 1, so we're good on that step. 3 says divide the x term, our linear term, coefficient by 2. So we're going to take 4 and divide it by 2, which is 2. Square that, 2 squared is 4, and add it to both sides. So finally we have something that we can do. So again, we're taking that coefficient of the x term, we're dividing it by 2, and we squared it. 4 divided by 2 was 2, 2 squared is 4, added it to both sides. This results in a perfect square trinomial. Square root of x squared is x, square root of 4 is 4, multiply the two together and double it, gives us that middle term. So this trinomial factors into x, both signs are the same, both are plus a 2, the quantity squared. Simplifying the other side, negative 3 plus 4 is 1. We're now ready to take the square root of each side using our principles of square roots. Square root of something squared is that something, and the square root of 1 will not only be positive 1, but it also can be negative 1. Solving then our last step for x, we have x plus 2 equals 1, or x plus 2 equals negative 1. subtract a 2 from each side to solve for x. We end up with a -1. Subtracting a 2 here, we end up with the solution of x is equal to -3. And we could plug those in to verify that we do have the correct solution. Let's look at another example. Same thing, they're asking us to simplify by completing the square. First step is to isolate the variables to one side. That means 67 needs to go to the other side. We'll leave our x squared plus 18x, the terms with the variables, but subtracting a 67 from each side or taking the term to the other side changes its sign. Next, we would divide every term by the coefficient of our quadratic term. If it was something other than 1, it's not, so we don't need to do that step. Moving on, we take the coefficient of our x term, which is 18. We are going to divide it by 2, which will give us 9, and then we will square it, which gives us an 81. We will add an 81 to both sides of the equation, which is going to give us a perfect square on the left. Square root of x squared is x, square root of 81 is 9, multiply the two together does give us the 18x. So we have a perfect square trinomial. We can replace this with an x and a 9 in our first term and second term. Both signs are the same, both are positive, and the quantity is squared. In the meantime, we'll combine -67 plus 81, which is going to leave us with a positive 14. We now can use our principle of square roots, taking the square root of each side. The square root of a quantity squared is that quantity. Square root of 14 can both be a positive and a negative square root of 14, and we can't simplify that radical. But we can solve for our variable now for the last step for completing the square. Separating this into the two solutions, x plus 9 equals a positive square root of 14, or x plus 9 equals a negative square root of 14. The only thing to do is to take our 9 to the other side by subtracting it from each side. These aren't similar terms, so here is one solution. X can be a -9 plus square root of 14, or our second solution, subtracting a 9 as well to get x by itself, will give us x is equal to -9 minus the square root of 14. We have another example here where we're asked to simplify by completing the square. First step is to isolate the variables to one side. That means we'll add a 3 to both sides to take that constant term to the other side. Next step, and here we actually can do this, we want a leading coefficient of 1. So we need to divide all terms by this coefficient on our x squared term to eliminate it. So we will divide by 2 every term to maintain equality. The 2's cancel out, leaving an x squared. We have a 5/2 x, and we end up with a 3/2. We now have a leading coefficient of 1. We're ready to move on to step 3. We're going to divide the x term by 2. So the coefficient of our x term is 5/2. They're asking us to divide it by 2, which would give us a complex number. Dividing by 2 is the same as multiplying by 1/2. That gives us a 5/4 that we then will square. 5/4 squared ends up giving us a 25, whoops, wrote a 4 there, 25/16. 5 over 4, 5 times 5 is 25, 4 times 4 is 16. And what we do to one side, we need to do to the other. So we will add that 25/16 to the other side as well. We now have a perfect square trinomial where the square root of the first term is x, the square root of our constant term is 5/4. Multiply the two together would give us 5/4 x. Double it, cancels out the 2 and gives us the 5/2 x. So it does meet the criteria for a perfect square trinomial, and if you're following the steps, you should have a perfect square. Both signs are the same, both are positive, so this factors into x plus 5/4. The quantity squared is equal to, adding here, we need to get a common denominator, so we'll multiply top and bottom of the first fraction by 8. That gives us a 24/16 plus 25/16, resulting in a 49/16. We're now ready to take the square root of each side. Square root of a quantity squared is that quantity, x plus 5/4. And square root of 49/16 will be not only the positive but also the negative of square root of 49, which is 7, square root of 16, which is 4. To find the solutions, we'll separate that. X plus 5/4 equals 7/4, or the quantity x plus 5/4 is equal to negative 7/4. Solving, we'll subtract a 5/4 from each side. Good news is we have common denominators, so we don't have to worry about that. 7/4 minus 5/4 leaves us with a 2/4, which if you can reduce, always a good idea. So x is equal to 1/2. Here, subtracting a 5/4 on our second solution. Again, we have common denominator. Negative 7/4 minus 5/4, or plus a negative 5/4, leaves us with a negative 12/4, and simplifying gives us a solution of negative 3. So our solution to this quadratic equation is x is equal to 1/2 or a negative 3.